this problem subspaces, we are given a 4 by 5 matrix, and the first thing to do is to reduce this into the row echelon form. So we have this. I am going to add the first row to the second row to reduce the second row, and then add the first to the fourth to reduce by multiplying by -1 first to reduce the fourth row there. So R1 plus R2, and that is going to be R2, while negative R1 plus R4 is going to be R4. Alright, so let's see what we have here. We have 1 there still, -2. Row 1 and row 3 is going to be identical, while row 2 is going to be 0, -2 plus 3 is going to be 1, 1 here, while 3 there and a 0 right there. 3 is going to be kept the same. 3 and 4. 1 times -1 to the last row there is going to be 0 here, and a 4 there. -1 plus 5 is going to be a 4, and then -1 plus 13 is going to be 12. -2 plus 5 is going to be 3. I just want to make sure just in case. Yep, everything checks out. And next I am going to multiply the top row by -4, or the second row by -4, add it to the fourth row. So -4 R2 plus R4, and that is going to change R4, while the second row once again, make it negative, add it to R3 to change R3 there. I'm going to get from by multiplying the second row by -4 added to the fourth row there. So the top -2, 1, 1, and 2. The first row there is going to stay the same. Second row is going to stay the same as well. And the third is going to be 0, 0, 0, 0, 4. While the last one is same thing, except for the last going to be 3. Alright, so I'm left with this 4 and 3 right here. I'm going to take care of this 4 by multiplying it by 1/4. And the 3 right here. So after doing 1/4, R3, change that to R3. I'm going to end up with a 1 right here, and I will multiply that 1 by a -3 afterwards to get and then add it to the last row here to get a 0. To get a 1. So I'm going to do that first. 1, -2, 1, 1, 2. 0, 1, 1, 3, 0. Doing that, we're left with a 1 at the end, and 0, 0, 0, 0, 3. So now I can multiply the third row by -3 and then add that to the last row. And I'm going to end up with the same matrix, except for this part is going to be 0, which 1, -2, 1, 1, 2, 0, 1, 1, 3, 0, 0, 0, 0, 0, 1, 0, 0, 0. Now we have our reduced row echelon form of 1, -2, is not 0. This is 1, 1, 3, 0, 0, 0, 0, 0, 1. And our last row is going to be all zeros. Alright, our next step is to find, well, the next step is to find the row of A in a subspace of blank. So we know that this subspace is going to be in an R5 because there are 5 columns here. But the row A, we're going to focus on the leading term of each of the row. So in here we have 1, 1, and 1 only in the 3 rows. Therefore, row A is in a subspace of R5 here. But in finding the basis, we're only going to focus on these first 3 rows. And you can find that you can use either the reduced row echelon form here, or you can use that from the matrix A. So I'm just going to write it down. I'm going to use the vectors from this the reduced form here. And then we have 0, 1, 1, 3, 0. And the third one is going to be all zeros except for the last one. So now we have our 3-dimensional subspace in the 5-dimensional vector space. And so for the column A here, it's going to be the subspace of R4. And the reason for that is because in each of our column, we have 4 slots to put in the numbers. Therefore, it's a subspace of R4. However, the basis, we're going to look at the leading one in each of the column there. So we're going to have this 1 right here, 1 here, and 1 there. But the only difference for the basis of the column is that you cannot use the reduced row echelon form. You actually have to use it from the vector space of the matrix A. So basis for column A is going to be this guy, and the last one right there. So 1, -1, 0, 1. -2, 3, 1, 2. And our last one is 2, -2, 4, and 5. Alright. So our next one is finding the null of A is a subspace of same thing. It's going to be in a subspace of R5. However, when we're finding the basis of null A, it's going to be, so the nullity of the matrix A plus the rank A. Rank A is a number of the basis for either the row or the column, but generally we do it with the row. And that is going to equal the number of columns, which is our n. So the number of columns here, I'm actually going to skip a step and do the G part first, since we know all the numbers here. The number of columns is going to be 5. We have 5 columns there. And our rank is actually going to be the basis, the numbers of vectors in our basis, which is 3. And 3 plus 2 is 5. So we know that our nullity in the matrix A is going to be 2. Now in finding the basis, do I have enough space here? Yeah, okay, perfect. In finding the basis, we'll have to use the reduced row echelon form. So for each of these, each of these is x1, x2, x3, x4, x5. And we have 3 rows here. I'm going to use all 3 of those rows. And let's see, so I have 1 x1 by using the coefficient there, minus 2 x2 plus x3 plus x4 plus 2 x5. And since it's a null, you want it to equal 0. The second row would have x2 plus x3 plus 3x4, 0 and equals 0 again. And then the last one would only have x5 equals to 0. So since we know x5 is 0, and we have these 3, x2, x3, and x4 here, we can back substitute it, and we're going to assign 2 of them the parameters. Alright, so I know that x5 equals 0. I'm going to let my x4 equals to t, while my x3 is going to be s. Alright, now I'm going to substitute these into our original equation here with x2 solved, and I would have minus, instead of writing x3, I'm going to write s, and x4 here, I'm going to write t, since I'm parameterizing it, 3t. Going to do the first one same way with x1. The x2 here, I'm going to substitute it with the negative x minus 3t here that I just solved for. So I would have minus, or minus brought to the other side, be plus 2, open parentheses with negative s minus 3t, plus x3 now is going to be s, x4 is going to be t, minus t, minus for both of these. Thank you. And our x5 is going to be 0, so that's just going to be that. Now I'm going to combine like terms, and I will end up with negative s minus 5t. Cool. Alright, now that I have these, I can now write out the basis of the null space by using the matrix of all our x's there earlier, 3, x4, and x5. Now since I'm parameterizing it with s and t, I'm going to factor those s and t out. Plus t from the x's and y, and x's earlier. And I'm left with, so for x1, s is going to be a negative s, therefore, since I factor out the s, I'm left with a negative 1 in there for x1, and x2, same thing there. x3 is actually just an s, so I'll have 1. x4 is a t, therefore it has a 0 in there for x, and then x5 is going to be 0. x5 is actually going to be 0 for both of them. And x1 for t there, I'm going to have a negative 5. And x2, negative 3. x3 is going to be 0 for the t, and then x4 is 1. There you have the basis for a null space.